We're talking about inventing brand new organisms in a lab, programming cells like software, and designing life from scratch. Exciting? Absolutely. Legally messy? Even more so. So what happens when your breakthrough refuses to stay in its petri dish? When it divides, duplicates, and dares to defy old school legal categories? This isn't science fiction. It's synthetic biology. And the law, well, it's scrambling to keep up. Today on Intangibilia, we explore the wild world of intellectual property when the invention is alive, multiplying, and maybe just a little rebellious. Buckle up, bio nerds. It's about to replicate.
You are listening to Intangibilia, the podcast of intangible law, plain talk about intellectual property. Please welcome your host, Leticia Caminero.
Hello, everyone, and welcome back to Intangibilia, the podcast where intellectual property gets personal, global, and occasionally genetically modified. I'm Leticia Caminero, your host, here to guide you through the twists and turns of innovation and the laws that try to catch up.
And I'm Artemisa, your co-host, built from equal parts biotech obsession, AI training, and a pinch of legal mischief. I may not be a licensed attorney, but I do know this. If your invention uses DNA from a mysterious tropical frog stored neatly in a lab freezer, do you have to share credit? Spoiler, yes. And probably the profits too.
Today, we're diving into synthetic biology, lab-designed organisms, programmable cells, and inventions that don't just sit still, they replicate, sometimes faster than the law can.
Which makes today's episode a legal field trip through biolabs, courtrooms, and even a shiny new WIPO treaty. We'll unpack the basics, stroll through some unforgettable case law, break down what the treaty actually changes.
It's law, it's science, it's alive. Let's get into it. Before we begin, a quick disclaimer. While Artemisa is AI generated and I am fully human, nothing in this podcast is legal advice. We're here to inform, entertain, and stir some strategic thinking. Always consult a qualified lawyer in your jurisdiction before making any big moves in the patent world. Synthetic biology is a field that blends biology, engineering, and computer science to design and construct new biological parts and systems. Imagine programming DNA the way you'd program a microchip, or creating entirely new organisms in a lab that have never existed in nature. Ooh. But if you're inventing life, how do you protect it? Can you patent something that reproduces itself? Can a gene sequence be copyrighted? Spoiler, no. And should inventors share benefits if the raw material came from a rainforest, a coral reef, or even a freezer full of rock samples? These are the legal dilemmas synthetic biology raises. It also creates a policy headache. Traditional IP laws were made for machines and chemical formulas, not self-replicating bacteria or AI-designed yeast.
Exactly. IP law likes clean categories. Who invented it? What does it do? How is it new? But synthetic biology is not clean. It's wild. Some inventions start with natural genes and get tweaked. Others are fully built from scratch using computers. Some multiply, some mutate. Some are designed to spread on purpose like gene drives, and some raise serious ethical questions.
Now, a quick clarification. You might be wondering, what about plant variety protection? Isn't that already a system to protect living things?
It is, but not this kind. Plant variety protection, or PVP, is a special system used mostly for crops. It's meant for new plant varieties developed through traditional breeding, like a new type of tomato or wheat.
To qualify, that plant has to be distinct, uniform, and stable. Basically, it has to be a clearly defined variety that passes the farmer test. If you plant it, it grows the same way every time.
But synthetic biology often doesn't fit that mold. It's usually about microbes, cell lines, enzymes, or DNA sequences designed in a lab. These aren't traditional crops, they're living technologies. They might be programmable, self-replicating, or even part software, part biology.
So PVP doesn't apply. If you're designing a synthetic yeast that makes vegan cheese proteins, or a bacteria that cleans oil spills, you won't get plant variety rights. you'll need a patent.
And if your invention is a plant, like a gene-edited rice strain, you might qualify for both: a plant variety certificate for the whole plant and a patent for the genetic tweak inside.
But for most synthetic biology inventions, especially the ones coming out of biofoundries or digital labs, patents are the go-to tool. They cover genetic constructs, engineered traits, production methods, basically the design itself.
And that's where things get juicy, because when you start patenting living, evolving, multiplying inventions, the legal system starts to wobble.
Today, we're going to look at how different countries and courts have responded. We'll walk through some fascinating case law, a brand new WIPO treaty, and then throw in our wishful thinking for how the law could better match the science.
Because the future is alive, literally. And if you can build it with DNA, the world needs to figure out how to protect it or share it fairly.
All right, let's begin our legal journey where it all started, with a bacterium that eats oil and a Supreme Court that said, sure, you can patent that.
Oh, yes. It's 1980. Disco is still clinging on, and Ananda Mohan Chakrabarty is working at General Electric. But he's not designing refrigerators. He's designing bacteria.
Specifically, a genetically modified strain of Pseudomonas bacteria that can break down crude oil. This is a big deal for oil spill cleanup. Chakrabarty wants to patent it. The USPTO says no. Why? Because it's alive, and in their view, living things aren't patentable.
Which brings us to the showdown, Diamond v. Chakrabarty, heard by the U.S. Supreme Court.
The core question: can a human-made, genetically modified microorganism, something that doesn't exist in nature, be considered a manufacture or composition of matter under U.S. patent law?
The court said yes. In a 5-4 decision, they ruled that anything made by human ingenuity, including living organisms, can be patented as long as it's not a product of nature.
In this case, cracked the door wide open for biotech. Before Chakrabarty, life was mostly off limits in the patent world. After Chakrabarty, companies could start building IP portfolios around genetically engineered microbes, cell lines, and beyond.
Let's be clear, Chakrabarty didn't patent nature. He patented a new modified organism that didn't exist until he pieced it together gene by gene. That distinction became the foundation of biotech patent law in the US and inspired similar debates around the world.
And that ripple? It's still moving today. Many of the modern legal battles over synthetic biology trace their roots back to this one case. It's the reason your glow-in-the-dark bacteria, your insulin-producing yeast, your engineered enzymes can all be patented.
So thank you, Dr. Chakrabarty. You didn't just clean up oil, you cleaned up the definition of what counts as an invention.
So after bacteria made it through the patent office door, the next question was, what about plants?
And not just any plants. Hybrids, baby, genetically stable, high-performing crops that feed the world and rake in royalties. That's where Pioneer Hybrid comes in, with a whole portfolio of patented seeds.
Now, here's the legal twist. The US already had a special system for protecting plant varieties. It's called the Plant Variety Protection Act, or PVPA. So when Pioneer sued J.J. Mack Supply for selling patented hybrid corn seeds without a license, the defendants argued, wait, aren't plants only protected under the PVPA?
Boiler, the Supreme Court said nope. In a 6-2 decision, the court ruled that plants can be protected under both systems, the PVPA and utility patents, which are the regular kind we use for inventions.
That meant biotech companies could double down. You could claim exclusive rights over a plant variety and the genetic traits inside it, and the method used to breed or engineer it.
So let's break this down. With a PVPA certificate, you can stop others from selling or reproducing your plant variety. With a utility patent, you can stop them from using the genes, the breeding method, the tech behind it, and If you're savvy, the seed itself.
It was a huge win for agribusiness, but for small farmers and seed savers, it raised the stakes. The rules got tighter, the seeds got more expensive, and suddenly EP was growing in the soil along with the crops.
This case solidified that living inventions aren't just protected, they're layered like a genetically engineered onion. If Diamond V Chakrabarty gave us the green light, JMV Pioneer put us in the fast lane.
Now let's cross the border to Canada, where the same famous invention, the Onca mouse, ran into very different legal results.
Ah, yes, the genetically engineered mouse designed to develop cancer for research purposes. Glamorous, right? Harvard patented it in the US and Europe. So naturally, they thought Canada would be next.
But the Canadian Intellectual Property Office said no. And when Harvard challenged the rejection, the case escalated all the way to the Supreme Court of.
The question was simple, but the implications were huge. Can you patent a higher life form, not just a gene or a method, but the whole living, breathing, tail wiggling mouse?
And the court said, nope, not in Canada. In a 5-4 decision, the majority held that the Patent Act was never intended to apply to animals as whole entities. While they agree that genes and engineered processes could be patented, the complete organism crossed a line.
Which created this fascinating IP split screen. Harvard could patent the Onca moose in the US and Europe, but not in Canada.
The ruling didn't just draw a boundary, it reflected values. The judges emphasized that patenting higher life forms raised ethical, legal, and even philosophical questions that Parliament, not the courts, should address.
So while Chakrabarty opened the patent floodgates in the US, Canada built a dam. The result? Canada still protects biotech inventions, but it draws a firmer line when the invention has a heartbeat.
And that line continues to shape how Canada approaches biotechnology to this day. It's a reminder that IP law isn't just technical, it's also cultural. And next up, Dolly, the sheep, the celebrity clone who changed science forever, but couldn't get past the patent examiner.
She was adorable. She was historic. She was genetically identical to another sheep. And that, dear listeners, is where her legal problems began.
The Roslin Institute, a Scottish lab that created Dolly in the 1990s, filed for a US patent, not for the cloning process, but for the clone animal itself.
The argument was, hey, we made her. She didn't exist in nature. Give us the patent. But the US Patent Office said she's identical to an existing sheep. That's not invention, that's duplication.
So Roslin appealed, and in 2014, the US Court of Appeals for the Federal Circuit ruled against them. The court held that because Dolly was genetically indistinguishable from her donor, she was not markedly different from a natural organism and therefore not patentable.
In translation, you can't get a patent for just copying nature, even if it takes a lot of science to do it. Dolly was a scientific miracle, yes, but not an IP one.
Chakrabarty legacy. Yes, you can patent an important nuance to the Chakrabarty legacy. Yes, you can patent a living organism if it's been modified in a way that makes it new and distinct. But if it's just a cloned replica of something nature already made, the law says no.
So poor Dolly ended up in textbooks, headlines, and history, but not in the patent registry.
It's a classic example of how similar doesn't mean patentable, especially when we're talking about life. Next up, we trade cloned sheep for soybeans, specifically patented soybeans that just wouldn't stop growing. Welcome to the wild world of self-replicating inventions.
Let me introduce Vernon Hugh Bowman, a farmer, a risk taker, and the man who thought, maybe I can plant these soybeans twice and no one will notice. Spoiler, Monsanto noticed.
Here's what happened. Bowman bought genetically modified soybean seeds from Monsanto. These were Roundup Ready, designed to survive herbicide. He planted them, harvested them, and then instead of buying new seeds the next season, he replanted seeds from his own crop over and over again.
He thought it was fine. He bought them legally the first time. It's called the patent exhaustion doctrine. Once you sell a product, the buyer owns it and can use it as they wish.
But Monsanto said, hold on. While Bowman could use the soybeans he bought, he couldn't create new generations of patented seeds without a license, because every new plant was a copy of their invention.
And the U.S. Supreme Court agreed. In 2013, they ruled unanimously in favor of Monsanto. Patent rights do not get exhausted when the product reproduces itself.
Why? Because allowing someone to replant patented seeds indefinitely would destroy the value of the patent. One purchase would lead to infinite reproduction, and no one would ever pay for innovation again.
This case drew a bright red line. You can use the patented thing, but you can't copy it, especially if that copy happens to sprout out of the ground.
It also reminded everyone that self-replicating technologies, whether seeds, software, or cell lines, need careful handling under EP law. And that, yes, in the world of biotech, seeds can sue. Next, we head to Brazil, one of the largest producers of soybeans in the world, for a landmark case about patent expiration, technology fees, and farmers' rights.
This one centers on a genetically modified seed called Intacta RR2 Pro, developed by Monsanto and later acquired by Bayer. These seeds were engineered to resist pests and herbicides and were widely used across Brazil.
For years, farmers paid a technology fee, a royalty, for using the seeds. That's standard practice while a patent is still active. But in 2018, the patent expired.
And here's where things got complicated. Even after expiration, royalty fees were still being collected. And many farmers said, wait a second, if the patent is no longer valid, why are we still paying?
The matter escalated to Brazil's Supreme Court. And in 2023, the court ruled that Bayer must refund the farmers for post-expiration royalties. The judgment was significant, not only in value, reportedly over 1.3 billion reais, but in principle.
The court emphasized a clear idea. Once a patent expires, its protections expire too, and the technology, no matter how valuable, enters the public domain.
This decision reaffirmed the time-bound nature of patent rights. It also reflected Brazil's commitment to a balanced IP system, one that supports innovation, while also safeguarding economic fairness and legal certainty.
It's a powerful reminder for inventors and IP holders. Patents are temporary monopolies. Once the clock runs out, access opens up. That's part of the deal.
And this case will likely guide future licensing practices across agriculture, not just in Brazil, but in other countries watching closely. From soybeans, we move to something even juicier, tomatoes and broccoli. Yes, this next legal battle is about whether plants produced through traditional breeding, not genetic engineering, can be patented.
Let's set the table. 2 European biotech companies applied for patents on new tomato and broccoli varieties. But these weren't GMO plants. They were created using conventional breeding methods, the kind farmers have used for centuries.
The European Patent Office granted the patents at first. But critics pushed back, arguing that essentially biological processes like natural crossing and selection shouldn't lead to exclusive rights.
So the legal question became, if the process isn't biotech, can the product still be protected? Can you patent the tomato, even if the breeding method wasn't technical?
In 2015, the APO's enlarged Board of Appeal said yes. It ruled that while the breeding method itself couldn't be patented, the resulting plant could be.
That caused a stir. Farmers, breeders, and activists said, wait, are we really patenting vegetables from traditional agriculture now? The backlash was strong.
So in 2020, the EPO reversed course. In Decision G3/19, it ruled that plants and animals obtained exclusively through essentially biological processes are not patentable. that closed the patent window for conventionally bred crops across Europe.
The outcome marked a rare policy U-turn at the EPO. It was a clear message that Europe wants to draw a line between invention and discovery, between biotech innovation and traditional breeding.
And that's important. This case shaped how patent offices across the region think about agriculture, food security, and where innovation begins and ends.
Also, it taught us that tomatoes and broccoli can do more than fight in your fridge. They can fight in court.
Intangiblia, the podcast of intangible law, plain talk about intellectual property.
Now we head to a case that goes beyond labs and courtrooms. It reaches into centuries-old traditions, healing practices, and community wisdom. Let's talk about the neem tree.
Used for generations across Asia and Africa, neem is a medicinal powerhouse. Its seeds, bark, and oil are known for treating infections, serving as insect repellents, and, relevant here, acting as a natural fungicide.
In the 1990s, a European patent was granted to a company that extracted a fungicidal formula from neem and filed it as a new invention.
But here's the twist. This new invention was already well known and used traditionally in India and other regions. It wasn't a discovery. It was a case of what many may call biopiracy.
Environmental groups and the Indian government challenged the patent at the European Patent Office, arguing that neem's antifungal use was prior art, meaning it was already known and used publicly, just not documented in Western journals.
And in 2000, they won. The EPO revoked the patent, agreeing that neem's properties weren't new or inventive. The knowledge may not have been written in a patent application, but it had existed in practice for centuries.
This decision became a turning point. It put traditional knowledge on the global IP radar and sparked discussions about how to recognize, respect, and protect community health wisdom.
It also fueled momentum for access and benefit sharing and contributed to the rise of legal tools like the Nagoya Protocol, because when people use local biodiversity, the local communities deserve a seat at the table.
This case reminds us that innovation doesn't always come from labs. It also grows in forests, kitchens, and oral traditions. And IP law has to evolve to include those spaces too. Next up, we turn to a case that landed at the intersection of genetics, medicine, and morality. Association for Molecular Pathology, v. Myriad Genetics. It's one of the most famous biotech IP cases in U.S. history.
Here's a setup. Myriad Genetics had isolated two genes, BRCA1 and BRCA2, which are linked to a high risk of breast and ovarian cancer. Myriad didn't invent the genes, but they did find them, isolate them, and develop tests based on them.
They filed for patents not just on the tests, but on the isolated gene sequences themselves. And they got them. For years, Myriad had exclusive rights to those genes in the US.
Which meant if your doctor wanted to test you for BRCA mutations, they had to go through Myriad. That raised prices, limited access, and sparked outrage from researchers, doctors, and patient groups.
So a coalition of medical organizations and civil rights groups sued. And in 2013, the US Supreme Court ruled that naturally occurring DNA sequences are not patentable, even if isolated in a lab.
But there's a twist. The court drew a line. While natural genes aren't patentable, synthetic DNA, called cDNA, is. Because cDNA is created in the lab and doesn't occur in nature, it qualifies as an invention.
This case clarified one of the most fundamental questions in biotech: where does nature end and invention begin?
And it sent ripple effects around the world. Suddenly, patent offices had to rethink thousands of gene patents. Biotech companies had to redraw their IP strategies, and scientists gained more freedom to study human genes without hitting a paywall.
Most importantly, patients gained broader access to life-saving diagnostics. It was a legal milestone with real-world consequences. Now let's head to Australia, where the same company, Myriad Genetics, found itself in another legal showdown. Same BRCA1 gene, same isolated sequence, different court, different continent.
This time, the challenge came from Yvonne Darcy, a breast cancer survivor who believed that no one should be able to claim ownership over human genes, especially not those linked to life-threatening illnesses.
The legal question was almost identical to the US case. Is an isolated gene sequence taken from the human body and purified in a lab patentable in Australia?
At first, the federal court said yes. They ruled that isolating a gene made it sufficiently different from what exists in the body. But then came the appeal, and in 2015, the High Court of Australia unanimously disagreed.
Their logic? Even though the gene was isolated, its information content, the actual genetic code, remained the same. And that information wasn't something created by human ingenuity. It was found, not invented.
So, just like in the US, the court said no patents on naturally occurring human genes. It was a big win for public health advocates and researchers in Australia.
And a global message to biotech companies: if you're building your IP strategy around gene sequences alone, you're probably on shaky ground.
But remember, this doesn't block patents on synthetic genes, diagnostic methods, or novel gene editing tools. It just keeps the raw code of life open to all.
Together, the US and Australian Myriad cases reshaped how genetic material is treated under patent law, and they reinforce a powerful idea: discovery is not invention. Now we head to Europe for a case that didn't just test science, it tested ethics. The case? Brussels v. Greenpeace, decided by the Court of Justice of the European Union in 2011.
The conflict, a patent granted to German neuroscientist Oliver Brussel for a method of producing nerve cells from embryonic stem cells. It had promising applications in treating neurological disorders like Parkinson's.
Challenge, but Greenpeace filed a challenge not for environmental reasons, but moral ones. They argued that the process involved destroying human embryos, which should not be allowed under European law.
So the CJ&U had to decide, is an invention unpatentable if it requires the use and destruction of human embryos, even if the goal is medical?
And the court ruled yes. Under the EU Biotech Directive, inventions involving the destruction of human embryos for industrial or commercial purposes are excluded from patentability.
The court's reasoning was grounded in respect for human dignity. Even if the process is scientific, even if the benefits are enormous, the act of destroying embryos cannot be part of a patentable invention.
That decision sends shockwaves through the biotech sector. It didn't outlaw stem cell research, but it meant that certain types of embryonic stem cell inventions couldn't be patented in the EU.
It was a defining moment for bioethics in patent law, and it drew a sharp line between what's technically possible and what's legally or morally acceptable.
The ruling also pushed many labs towards alternative research paths, like induced pluripotent stem cells, which don't involve embryos at all.
So while Brussels lost the patent, the case helped guide a generation of scientists toward ethical innovation and reminded us that not all breakthroughs belong on a balance sheet.
Now let's explore the foggy middle ground of biotech patents. What happens when you discover a new gene, but you don't fully know what it does yet? Enter the UK case of Human Genome Sciences v. Eli Lilly.
The year was 2011, and Human Genome Sciences, or HGS, had identified the sequence for a protein called neutropenia. They believed it belonged to the tumor necrosis factor, TNF family, which is involved in immune system responses.
So they filed for a patent on the gene and its potential applications, even though its exact function wasn't fully understood. Then Eli Lilly challenged the patent, arguing it lacked industrial applicability, which in UK and European patent law is like the equivalent of utility.
Billy said, if you don't know what this gene does, how can you claim it has a practical use? It's a fair question. Patent law doesn't reward fishing expeditions.
But HGS argued that based on the gene structure and its relation to the TNF family, its role in the immune system was plausible, and that was enough.
And the UK Supreme Court agreed. They reversed the lower court's decision and upheld the patent, aligning with the European Patent Office's more flexible stance.
The ruling made a big statement. You don't need full scientific certainty to patent a biotech invention as long as there's a credible and plausible use grounded in existing knowledge.
That's great news for gene hunters. It means you don't have to wait until a gene becomes a blockbuster drug. If the science supports a reasonable function, your discovery might qualify.
But it also walks a tightrope. Granting patents too early before true utility is confirmed can lock up whole areas of biology and slow down progress.
Still, this case gave clarity to European biotech innovators and showed that timing, plausibility, and context all matter in the race to protect genetic IP.
We've reached the final boss of biotech patent battles, Broad Institute v. University of California, Berkeley, the CRISPR case. It's technical, global, and still unfolding.
CRISPR-Cas9 is the gene editing tool that changed everything. With it, scientists can edit DNA with extraordinary precision, like a molecular scalpel. It has the potential to cure genetic diseases, improve crops, and rewrite biotech as we know it.
Here's the issue. In 2012, UC Berkeley, led by Jennifer Doudna and Emmanuel Charpentier, filed a patent for using CRISPR in prokaryotic cells like bacteria. A few months later, Broad Institute, affiliated with MIT and Harvard, filed its own patents specifically for using CRISPR in eukaryotic cells like humans, plants, and animals.
Both sides claimed to be first. Both had published results, but Broad paid extra for expedited review and got their patents approved first. That's when the fight began.
The legal question was, did Broad invent something new, or were they just building on what UC had already made public? The Patent Trial and Appeal Board, PTAB in the US, initially sided with Broad, saying there was no interference, meaning the two inventions were distinct enough.
But UC Berkeley appealed and a series of challenges followed. Across the Atlantic, the European Patent Office took a different view, revoking Broad's patent on procedural grounds related to how inventors were listed.
This case is still evolving. Between 2015 and 2025, multiple rulings have shifted the balance. Broad has held strong in the US, while Berkeley has gained more ground in Europe and elsewhere.
It's not just about credit, it's about billions in licensing deals, the future of gene therapies, and who gets to shape the next generation of biotech.
And it's taught us a lot how patent strategy, speed, global coordination, and legal precision all matter in high-stakes science.
So while the gene editing revolution is advancing fast, the legal framework is still catching up. One nucleotide, one court date at a time.
So far, we've traveled through labs, fields, cores, and petri dishes. But there's one more major development shaking the roots of synthetic biology, IP, a brand new treaty from WIPO.
The ink's still drying. It was adopted in May 2024, and it's the first to focus on genetic resources and associated traditional knowledge.
For decades, countries rich in biodiversity, especially those with rainforests, coral reefs, and traditional plant-based medicine, have raised a fair point. If companies are using our genetic resources to invent new things, we deserve transparency and maybe a share in the benefits.
This treaty responds to that call. It doesn't ban anything, but it adds a layer of disclosure. Under the new rules, if you're filing a patent application involving genetic resources, You'll need to state where the material came from, and if traditional knowledge was involved, you disclose that too.
The goal? Transparency and fairness. It helps patent offices identify prior art. It deters biopiracy, and it strengthens trust between innovators and communities that have stewarded biodiversity for centuries.
And no, this isn't about blocking innovation. It's about building a system where innovation doesn't come at the expense of the people and places that made it possible in the first place.
Importantly, this treaty has global participation. Over 150 WIPO member states adopted it. And while implementation will vary by country, it sets a powerful baseline. If your invention involves a genetic resource, the origin matters.
And guess what? It even applies to synthetic biology. If your invention involves a gene from a frog, a fungus, or a fruit fly, and that gene came from nature, you may need to disclose where it came from, even if you're editing it with AI in a lab.
The treaty also opens the door to future legal clarity, especially for patents involving digital sequence information, biofoundries, and AI designed organisms. It's not fully settled yet, but it's a start.
It's a big moment. IP law is evolving, finally, to recognize that life, knowledge, and invention don't exist in a vacuum. They're connected. And now the paperwork will reflect that too.
Before we hang up our lab coats, let's break it down. Here are 5 takeaways from our journey through synthetic biology and intellectual property law.
1, living inventions can be patented, but only sometimes. From bacteria to CRISPR-edited cells, patent law allows protection when human ingenuity creates something truly new. But if it's too close to nature, courts will often draw the line. 2, self-replicating technologies need special legal care. Seeds that grow themselves, cells that divide, code that mutates. These challenge the limits of traditional patent rules. Bowman and Roslin taught us that replication doesn't mean free reuse. 3, disclosure is the new global standard. With the new WIPO treaty, inventors must disclose the origin of genetic resources and associated traditional knowledge. It's a transparency shift that will shape biotech filings worldwide. 4, global courts aren't always aligned, but they're converging. Myriad v. Myriad, Canada v. the OncoMouse, and the CRISPR battle show us how national systems diverge on ethics, utility, and inventorship, but also how they're learning from one another.
5, traditional knowledge and biodiversity are part of the EP equation. The NIM case and the new treaty both affirm that innovation doesn't only happen in labs, it also grows from ancestral wisdom. And now the law is starting to reflect that.
And that's your icebreaker kit for the future of synthetic biology. Whether you're editing genes or planting seeds, the rules of innovation are evolving and you just got the download.
That's it for today's deep dive into synthetic biology and intellectual property. We explore the building blocks of invention, the courtrooms where life gets debated, and the treaties shaping a more transparent future.
From gene patents to mouse dramas and bioethical standoffs, we've covered the full genome of legal tension. And remember, just because your invention can self-replicate doesn't mean your IP rights do.
Thank you for joining us on Intangible, where we decode the laws behind the lab coats and unpack the policies powering tomorrow's breakthrough.
Catch you next time. Same feed, same curiosity, brand new IP puzzle.
And until then, whether you're editing DNA, filing patents, or just daydreaming about bio-best futures,
keep it clever, keep it curious, and keep it intangible.
Thank you for listening to Intangiblia, the podcast of intangible law, plain talk about intellectual property. Did you like what we talked today? Please share with your network. Do you want to learn more about intellectual property? Subscribe now on your favorite podcast player. Follow us on Instagram, Facebook, LinkedIn, and Twitter. Visit our website www.intangiblia.com. Copyright Leticia Caminero 2020. All rights reserved. This podcast is provided for information purposes only.